Hello students, glad to have you back again. Continuing on our discussion of Earth cycles. In the last video lecture we went into the big picture. We talked about climate, we talked about ice ages and the oscillation of the temperature of Earth, such things as the precession of the equinoxes. In this chapter we're going to get back to more of what happens in our daily lives. What's the weather like today? So we're going to talk about the weather today. Weather is primarily a result of movement of air masses. I've shown over to the right just something from USA Today, the sort of weather report that you might find for particular locations, and that giving you projections of what the weather is going to be like. The daily weather report usually includes the temperature, the highs and lows, the atmospheric pressure, usually given in inches of mercury. Remember when we talked about different ways that pressure could be measured? One of the ways is in inches of mercury. We'll not go into it. You can also in the daily weather report, they'll usually talk about the humidity, which can vary from about 0.1% to several percent. Usually the humidity is given as a relative humidity. Also, whether or not it's going to be cloudy or not, the direction of the wind speeds. Okay. So these are the things that you usually see in a daily weather report. Again, it's important to stress that short-term variations are called weather. The state of an atmosphere at a given time, a given location. The weather will be different in Cleveland than Orlando, Florida, etc. Long-term pattern, long-term averages are called climate. Now, let's talk about some of these measurements again. Temperature. Temperature is measured at ground level, and temperature will decrease as you go up in the atmosphere above sea level or above the ground level until you reach the thermosphere. The highest average annual temperature of inhabited regions of the Earth is about 106 degrees. Now, there may be different places that vie for this. I saw another report that it was the high temperature was in a different location of maybe Australia or China or Iran. But high temperatures can go up to about 106 degrees Fahrenheit. And the lowest average annual temperature, an example would be Eureka, Canada, Eureka, minus 3.5 degrees Fahrenheit. The highest single day temperature ever recorded in a place called Furnace Ranch in Death Valley, California, very appropriate name, Furnace Ranch, was 134 degrees Fahrenheit. That is hot. Again, there may be other examples. I've seen others, the Lut Desert in Iran having 159 degrees. I guess different places can compete for the highest single day temperature. The lowest single day temperature ever recorded was in Vostok Station, Antarctica, and that was minus 128.6 degrees Fahrenheit. Thank you very much. Pressure, again, is the measurement of the stack of air, the weight of the air, and it can be measured in different ways. So we'll not go into it too much. Humidity usually is given as a relative term, and it's a percentage of the maximum water vapor that can be present at a given temperature and total barometric pressure. Cloudiness, clouds are concentration of tiny water droplets or ice crystals, and a band of clouds is usually associated with boundary between air masses, which we'll talk about in a few minutes. And of course also the direction of the wind and its strength is usually given in miles per hour. Let's talk about the general wind circulation patterns of planet Earth. Let's look to the left first and consider the situation hypothetically, if the Earth did not circulate, did not rotate on its axis. Due to convection, hot air rises and cold air sinks, right? So the predominant pattern, hypothetically, would be warm air coming from the equator would move towards the poles, either the North Pole or the South Pole, and that cold air from the poles would find its way down, would circulate down to the equator, and that you would have a pattern such as shown on the left. That would be if the Earth were not rotating, but it is rotating. Due to the fact that it's rotating, there's something called the Coriolis effect, and that results in a very different wind circulation patterns as shown on the right. This results in distinct circulation belts or patterns in the northern hemisphere and in the southern hemisphere. And a consequence of this is that the circulation patterns are clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Now let's talk about air fronts. Air fronts are boundaries between air masses, where the air masses themselves differ in temperature and moisture content. We will talk about warm air fronts and cold air fronts, warm bodies of air, cold bodies of air. I show in the middle of this slide a typical weather mat, and it shows one of these patterns with the little blue triangles and the red semicircles, and we're going to explain what this means and how this helps us understand the direction and the movement of air masses. It's actually the clashing of the air masses that leads to what we call weather, rain or snow or fog, or dramatic changes in temperature and wind direction. Air masses of different types, cold or warm, humid or not, are created above either land masses or above the oceans. And depending upon where the air masses are created or originate, they will either be cold and dry or warm and moist. And these air masses, due to convection and the rotation of the Earth, that is the Coriolis effect, they move. They move in certain patterns, which are somewhat predictable, not really, but somewhat predictable. We can have advancing cold fronts usually being drier masses of air and usually moving relatively rapidly. When you have an advancing cold front where it clashes with a warm front, the colder air staying closer to the ground sort of pushes the warm air forward, and rain and thunderstorms usually occur at this boundary between an advancing cold front and a warm front. We represent this on the map as blue darts or blue triangles. Now, because cold fronts advance more rapidly, the clouds and the storms, the rainstorms, the thunderstorms associated with an advancing cold front usually are in a more narrow pattern. A line of thunderstorms is what you've probably heard, usually result in cumulus clouds as shown in the picture to the left. An advancing warm front, let's say warm air, is created over parts of the southwestern part of the United States. An advancing warm front can, in some cases, depending upon whether or not it's created over land or over bodies of water like the ocean or the Gulf of Mexico, an advancing warm front can carry moist air with it. Warm fronts usually move more slowly, and when they meet a cold front, they will push the cold front more slowly in a particular direction. And because it's moving more slowly, there will be widespread rain and possibly fog associated with a warm front boundary. And this is usually represented by red circles or semicircles on a weather map. The clouds associated with an advancing warm front are usually stratus clouds, as shown in the drawing to the bottom right. Now, another type of weather event that we talk about in the news quite a bit is an El Nino event. This is another one of these cyclical phenomena that occurs fairly irregularly, but on a cycle of 2 to 7 years. What appears to occur is that there is a significant warming of the air masses of the water near the equator in the Pacific Ocean, just to the west of South America. And this warm air mass, when it moves, will bring different consequences to our weather. Usually in an El Nino year, the northern part of the United States experiences a warmer and drier weather pattern. The southwestern parts of the United States usually experiences a wetter or rainier weather, and the southeastern parts of the United States usually experiences a colder weather pattern. So this has been just a quick overview of weather. There are other things that we could talk about. We could talk about polar vortexes, which is in the news in some years, where if you remember those 3 different band regions of circulating patterns, where some of these patterns actually dip down further, bringing very cold Arctic air into the regions of the United States. And hopefully from this presentation, you'll have a little better idea about what the weather persons are saying when they report the weather to us on the Weather Channel. We'll pause again and have a brief quiz over this video lecture. And then when we return, we'll talk about the rock cycle. See you shortly.